Hi folks, I'd like to go retrospective and talk a little bit about homework 3b. First of all, I'd like you to print a solution. If you want to understand the problem, let's print the solution and add a bit of a comment to help you better understand this solution. Alright, first of all, the first point is we have to know that there are two factors that determine the curve number. One is land use, for example, trees, houses, or grass. The other part is soil. This texture, I mean this soil type B. By this circle, I indicate type soil texture, group C. Okay, so those two factors can randomly mix. Okay, they can randomly mix. For example, underneath the tree, you can have a soil type B, but you can also have soil type C. So here we assume random mixture between land use and soil. Therefore, because there's half of the area is wooded, out of this half, you have 60% of type B. Right? So half times 60% of that gives you the 0.3 here in the solution. Okay, that gives you the 0.3 here in this solution. Okay. Similarly, for type C, you have half times 40% of that. That gives you the 0.2 in the solution. Okay, the 0.2 in the solution. All right. Therefore, by looking at that, for each one of these combinations, wooded B, you have a curve number. Go into the table and find the curve number. Wooded C, you have a different curve number. Okay, that's what this solution is trying to explain. Wooded area with good cover, type B, you have curve number 2. Okay, then you go to this slide, which you provided in class, because what you read from the table, you got to 52 out of that land use and soil table, you read 55, but that is by default class 2. That is by default AMC type 2. Okay, to adjust for anticipated moisture conditions, you look at this table. This is what we provided in the slide. Okay, let's say you have a value, you read 55. Okay, then you look across. For type 1, you get 35. You get 35, and that's what we indicated in our problem, in our solution here. Your curve number 1 is 35, because that's adjustment. That's the adjustment for anticipated soil moisture condition. Okay. Similarly, you find out the curve number of type 1 for all of these different type combinations, and the key is we should not just average up these curve numbers. Okay, what we ought to do is calculate their respective Q using the equation, which is S is equal to 1,000 over curve number minus 10, and then you have the Q, or PE, is equal to P, precipitation, minus 20% of the S squared over P plus 80% of the S. Okay, you calculate this for every land use, then you area average them. So the way you area average them is, for this Q you do 2.225, and then you multiply by that fraction 30% plus 0.5 multiplied by this fraction 30%, then 1.21 times 20% plus 1.67 times 20%, you get the area average. Okay, here is 0.803, and that has a unit of inch. That basically indicate how much runoff you have per acre. Okay, per unit area, whatever that unit is. So this, because it's given in thickness of the water. And then you continue to do the same thing for the post land use change case, in which case there are now 6 different combinations. Again, you go and find out there's different curve numbers. You do the soil moisture condition adjustment through this table. Sometimes, okay, here I go from 55 to to 35, that's easy, right? If you have a number that doesn't directly show up in this table, you can do a linear interpolation. For example, you have 51, okay, like I showed before. You have 51, it goes inside this interval between 50 and 55, right? Then you can, and correspondingly, it goes from 31 to 35, right? Therefore, you can do 35 minus 31. Okay, you times this fraction of the walk, which is 51 minus 50 over 55 minus 50. And then you plus where it started, which is 31. And you get like an interpolated value for corresponding to 51. Okay, and sometimes your calculations might be off a little bit because of the different way you do interpolation, and that's okay because these things are not that precise. All right, I will stop with the problem 1.